Good evening, everyone. I am Shifali Agarwal, and I am a PhD scholar in IIT Madras in Civil Engineering Department. So this is our third TA session on design of steel structure. So as usual, we will first see whatever you guys have studied in the previous lecture, previous week, and then we will do we will solve some questions and answers for the ease of your assignments. So this is the outline of week 3. In week 3, you might have studied about design of butt welding, and then what are other type of welding like plug and slot weld, and how to do the design of these type of welding. And lastly, you might have studied about the eccentric connections, uh, mainly in load where load is lying in the plane of connection. And here you might have studied it in two parts. First is bolted joint and second is welded joints. So firstly, we have the design of butt weld. So as we have already studied what is a butt weld. What is a butt weld? In a butt weld, we are joining two plates in single plane. So when two plates are joined or any two elements are joined in a single plane, one plane, that is called as butt joint. So these are the different parts of our butt joint. This thickness of our plate is called as throat thickness. Then this area of our plate, this area of our plate, which is actually part of our welding, this is called as fusion zone. And then the extra part, like this much is the thickness of our plates, and this extra part, it is called as the reinforcement. Okay, so these are the different parts of a butt weld. So when we go for the design purposes, we have first thing is the size of butt weld. As we have seen in size of fillet weld, same way we will calculate size of butt weld. So size of butt weld is given by effective throat thickness of the of our weld. Okay, and we have two type of penetration. Like in this case, when our uh, two plates are completely till complete depth, the full depth they are welded. That is called as complete penetration. But if like if our welding is sorry, if imagine our welding is not till this point only, then it is called as incomplete penetration. Okay, mostly in case like V is made or examples are given like single V, single U, J, or single B will butt joint. So in case of complete penetration, what we will take as size of butt weld, complete thickness of our plate. So complete throat thickness will be taken as the size of weld. And in case of incomplete penetration, what we are doing, we are taking 7/8 of thickness of thinner part. So one or two plates are there, whichever is thinner, 7/8 of, so that thinner part will be taken as size of butt weld. And it should be minimum 5/8 of thickness. So maximum is 7/8, and for the purpose of stress calculation, we will take 7/8, and for the size of butt weld, for normally size of butt weld, we will take as 5/8 of thickness of thinner part. Okay, so this is the first thing, size of butt weld. Secondly is the effective length of butt weld. So what we will take as effective length is the length of the continuous full size weld, or it should not be less than 4 times the size of weld. So this is our size of weld, and then we are taking effective length of butt weld. So effective length of butt weld will be full size of weld, full size of weld, or it should not be less than 4 times the size of the weld. Okay. Third is the reinforcement. So this part, why this part is provided, why we are not providing our welding till the thickness only. So this extra part will increase the efficiency of our joint, right? Because this will create an extra area which is joined, and which will increase the compatibility of our welding. So, uh, and these extra part, the extra reinforcement part, we are not considering it for the calculation of our stresses. So next important point during the design of butt weld is that the thickness between two plates should not be more than 25% of the thickness, or 3 mm, whichever is more. So I think it is thickness of thinner plate. So this difference should not be more than 25%, like thickness of bigger minus thickness of small divided by thickness of small into 100. If we do, it should not be more than 25% or 3 mm, whichever is more. Second is if the difference is more than 25%, then we will provide tapering. This is called as taper. We will taper one end of our uh, plate. So we will provide taper of 1 in 5. Okay. So this was the main specification which we are considering for the design of butt weld. Next is the what are the different values which we are calculating for the design of butt weld. First is the uh, design strength. So how we are calculating a design strength? First thing we have to consider is whether our butt weld is in tension, compression, or shear. The design strength is governed by the yield point. Okay, it is not governed by the ultimate point, it is governed by the yield point. So in tension or compression, our design strength is given by Lw into Te into Fi divided by gamma Mw. So what are the different terms here? Lw is the effective length of weld, and Fi will be the yield strength, yield stress of weld, and Te will be the effective throat thickness. Gamma Mw will be the partial safety factor. So in IS 200, IS 800, gamma Mw is given as 1.25 if our welding is shop welding, and 1.5 if our welding is site welding. Next is the in terms of shear. In shear, how this design strength is given by is the same value divided by under root of 3. So all these formulas are already given in IS 800. You can read from there. Next is these are the design strength. Third point is the stresses due to individual forces. So uh, shear stress or normal stress, if we have to calculate any type of stress, either axial stress or shear stress, it will be given by load upon area, right? Stress is load upon area. So load will be the axial force or normal force, and area will be given by our throat thickness and effective length of weld, right? So these are the different design parameters of our butt welding. Next is if there is, uh, you have any doubts,
Ma'am,
Shikhar?
yes.
No.
I mean, we have an condition like length of effective length of weld. It should not be less than 4 times the size of the weld, right?
Yeah.
I mean, if it is less than 4 times. If it, I mean, will it not? Will the formulas will not be considered for them, or what happens? Like, will that welding will be of no strength, or I mean, what happens? What is significance of that? If it is less than 4 is
These are just the specification given by IS 800. Normally, we have to follow these things on the site. If it
okay,
is less than 4 times of size of weld, that means our design is incorrect.
okay, okay, right. So in that case, we have to reduce the size of the weld and we have to do it again.
Yeah. No, we can't. We cannot reduce the size of the weld. That means we have to increase the effective length of our butt welding.
Okay, got it.
So next is if we have combination of stresses. In case of fillet weld, if our weld is subjected to different stresses, normal stresses and shear stresses together, this is the case when it is only tension, when it is only shear. So if it is governed by both normal as well as shear stresses, then our stress is given by FA square plus 3Q square. FA is a normal stress and Q is a shear stress. Okay, and it should be less than equal to Fu. Fu is ultimate stress. Ultimate stress given, it will depend on our grade of steel. Fu divided by under root 3 gamma mw, partial safety factor. And if we have three type, bearing, bending, and shear, all three type of stresses are there. In that case, our ultimate stress is given by FB square plus FBR square plus, this is like A square plus B square plus AB plus 3Q square. So F is a equivalent stress. Equivalent stress is given by due to bending, and FBs are due to bending, FBR is due to bearing, and Q is due to shear stress. So this all formulas will be given in our IS code. I don't think you have to remember all these formulas, which it will be given to you. Next is the plug-in slot welding. So normally we have studied about two type of welding, fillet weld and butt weld. In fillet weld, what we are telling are two plates are connected together at some angle or not in plane. In butt weld, we are telling both the plates are connected in a single plane, like end to end. And the other type of welding is plug-in slot welding. In plug-in slot welding, what we are doing, we are joining two plates on with each other at the surface, and then we are creating some hole, like we are creating some hole at the top and filling it with the welding. Okay. So, what is the difference between two type of welding is in plug welding, this slot or plug, whichever whatever we are studying, is created in the topmost plate is fully filled with the welding. So small slots are created and they are fully filled with the welding. That is called as plug welding. In slot welding, what we are doing, our a slot will be created and welding will be done only at the edges. It won't be complete penetration. Okay. In this case, what we are doing, we are completely filling it with the metal and welding it. In slot welding, we are just joining the edges. Like in this case, we will just join the edges. So that will be a slot welding. So these are the different specification for plug-in slot welding. It is given in IS 816, not in 800. The width to diameter of slot should not be less than 3 times thickness of the part in which the slot is formed, or 25 mm, whichever is greater. Next is the distance between edge of the part and edge of the slot or between adjacent slot or plug should not be less than 3 times the thickness of thinner member, or 25 mm, whichever is greater. Last is the corners at the enclosed end should be rounded to a radius not less than 1.5 times the thickness of the upper part, or 12 mm, whichever is greater. I think it's clear to everyone. These are the simple specification. You just have to go through them. If you have any doubt or any part which you think is you don't understand what exactly that part is here in this figure, you can ask me.
Ma'am, third point, can you show it in a figure kind of thing?
So if we see in this figure, this diameter, in this diagram, so we are telling at the enclosed end, this point, this radius, this radius we are talking about. So this radius, this part should be rounded. It should not be corner. Like in this figure also, you can see everything is rounded at the edge. So at every end, it should be rounded. And this round part radius should not be less than 1.5 times the thickness of upper plate. So this radius should not be less than 1.5 times the thickness of this plate. Like so this is the thickness. Or 12 mm. Okay.
Yes, got it.
So these are the different type of welds and how we have to design them. Next is the eccentric loading. So Eccentric loading means when our two plates which are joined together and but loading is not on the plane of our plates. So if in this case, um, if we have two plates connected and this is our CG point, if our load is acting on this point, that is our normal stress. But if our load is acting on some other point at at a distance E from our CG point, then that is called as eccentric loading. So, like this is an example where this one C channel and one plate is connected, one bracket plate is connected, and load is acting on one corner. So this is the front view of this image would be looking like this, right? So in this case, this is a CG line, but load is acting at this point. So how we will design this kind of thing is first we will see for the bolted joint. So in this example, let us assume we have 5 bolts, okay? And a load is acting at this edge P at a distance E from the CG. So two things are happening. One is axial load is acting. So two type of force will be there. One which is counteracting this axial force in vertical direction. Here in this case it is F1. Secondly, because of this eccentricity, a movement will be created. A movement of PE will be created at the CG point. So to counteract this movement, another force will be acting. Let us say it is F2. Okay. This force will be at the 90-degree angle of our radial distance. Right. So these two type of forces are clear. So we will see the how we will calculate these forces. So first is F1. F1 is due to direct load. So P and F1. So F1 is calculated by P by N. So F1 is equal to P divided by number of bolts. Right? Like 5 times F1 is equal to P. We can see from the figure 5 times F1 is equal to P. So F1 will be P by 5. So F1 is P by N. Second is F2. F2 is due to movement which is created PE. So how we will give force due to movement is this force will be proportional to our radial distance R, right? This this F2, it is proportional to radius distance R. It is normally at 90 degree of our radial distance R. So F2 is equal to some constant KR. Now how to calculate this K value? So we are, let us use movement of forces. We will calculate movement of forces at point at our CG point. So this is our CG point. At this point, sigma of F2. So this sigma of F2 into R. F2 into R will be equal to P into E, right? At this point, F2 into R is equal to P into E. So in place of F2, we will keep KR. So K into R square is equal to P into E. From there, F2 we can calculate as P, PE, or we can write it as moment also, PE into R divided by sigma R square. Okay. And our resultant force will be given by same, this F1 and F2 are at some angle. So resultant force will be in between. This resultant force F R is given by under root of F1 square plus F2 square plus F1 F2 cos theta. 2 F1 F2 cos theta. Right? This is a simple mathematical issue. I think you all know about it, right? So what is this theta angle? This theta angle is the angle between F1 and F2. This angle theta is given by this is this angle between F1 and F2. Okay. If anybody have any doubt in this calculation, you can ask me now. Okay. Is clear? Then we will go to the next slide. Next is the design procedure of eccentric loading in bolted joints. So here, what we are doing, first we will assume some diameter of our bolt, and then we will find the strength of one bolt, the same formula we are using, which we are doing in the bolt design. We will calculate the strength value, and we will get the bolt value BSD. So if our moment value, if our moment value is very low, then we will calculate number of bolt as P divided by bolt value BSD, and to find the approximate, increase the number of bolt to certain percentage, and then arrange the total number of bolt in two or more vertical lines. So we got number of bolts, then we will arrange those bolts in some in any vertical arrangement, and we will assume some pitch, and we will assume our pitch spacing and edge distance. All these things we are assuming. Then this is in the case when we have very less of movement is very less. But if our movement is very high, then we are calculating our number of bolts using this formula 6n divided by n dash. N dash is a number of bolt lines, like in this case 2, number of bolt line into pitch of bolt into BSD. BSD is our bolt value, which we are calculating from the strength. So same again, we will increase the number of bolts by 50% and then arrange our bolts in some particular lines. And then we will calculate our resultant force, the one which we have seen in the previous slide. We will calculate our resultant force, and if the resultant force is less than the bolt value, then the joint is safe. So our resultant force should be less than the bolt value, which we are calculating here, BSD. Okay, this is our design procedure. Next is the eccentric loading in case of welding. So first we have seen in case of bolts, and next we have seen in case of welding. So just make sure that all this eccentric loading we are doing in the load where load is in the plane of connection. So this is a plane of connection, and our load is acting in this same plane. So welded joint, same thing we have seen, that one plate and other plate are welded at for this area, and then load is acting in this point. This is our distance from CG, and this is given as our eccentricity at this edge, because this is weld joint. So this is not some point load, it is the complete area load. So that's why eccentricity we are taking from this point. And next is, so how we are calculating, we are assuming this is our y, this is our x, and this is our y. So our maximum stress will be at R. Why not at this point? Because this R is very small. So this stress will be smaller than this stress, right? Okay. So we will see the calculation for this thing. At this point, see, if this is our R and this is our R dash. So if we calculate our bending stresses, so more the R value, more will be the stress value, right? And therefore we are telling this is our critical point, this and this. These two are critical point, not these two. If somebody asks any question in chat box, I am not able to open it now. Okay, we will see it afterwards. Let me just complete this one. So how we are doing the calculation for this part is, firstly, we will get the CG of our welding. So this is our complete weld area. In this case, it won't be at the center of this plate. So we will calculate the CG of this complete weld. Let us assume this is our CG. Okay. So then from the CG, we are calculating different forces. So let's see step by step. So we are considering our size of weld as S. Throat thickness will be given as 0.707 size of weld. We have already seen those things. And now this is our vertical load P. This is our E eccentricity. So and this is our length of weld, total length of weld. So total length of weld is given by 2 times of B plus D. Okay. This is our D and this is our B. So 2B plus D will be given by total length of weld. So first thing is direct shear stress in the weld. Shear stress is given by load per area. Load is P, area is given by L into T. So L is equal to length of our this thing. Sorry, not this thing. This length of our weld, total length of our weld. This B 2B plus D L into T. T is equal to our throat thickness, right? So if this is our weld and this is of some, it will be of some thickness, right? So stress, direct shear stress is given by load into area. Area is 2 this 2B plus D into thickness. Okay, this is our shear stress. Now this is direct shear stress. Second is again a movement will be acting PE. So stress due to movement, it is given by movement divided by I into R. This formula we have read in structure analysis, right? Sigma upon R is equal to M upon I. Same formula we are using here. Stress is equal to M upon I into R. So this is our stress due to bending. So how what will be our resultant stress? It is a PS square plus PB square plus 2PS PB cos theta. Again, theta will be our angle between these two stresses. This angle, this will be our theta. Okay. This vertical line is a PS due to stress due to shear stress, and this line is a PB stress due to bending. So this is our resultant stress calculation, and IP is the polar moment of inertia for our weld, which is given by IXS plus IYY. This we will see how to calculate it further, or normally it will be given in questions. So this is what you might have studied in the previous week. If you have any doubt, you can ask me now. Then we will go to some question answer. If there is no doubt, then we will go to our question and answer session. So first question is, design strength of a butt weld is governed by yield for the axial loading as well as shear loading, yield for the axial loading and fracture for shear loading, fracture for axial loading and yield for shear loading, or fracture for axial loading as well as shear loading. This we have read in the first slide itself. What is the design strength of butt weld governed by? B. Okay. So if you go to the first slide, to go in first lecture, we were reading about like in tension or in shear. So mostly our design strength is governed by yield only. It is governed by yield for axial as well as shear loading. So answer is A. you want, I will show you. So design strength of a butt weld is governed by yielding in terms of tension and compression as well as in shear. Okay. Second, two plates of sizes 12 mm and 14 mm are joined together by incomplete penetration of butt weld. Calculate the maximum throat thickness for the purpose of stress calculation. How you will calculate it? I will give you 2 minutes. If you can calculate, you can write your answers. We will solve the question. So we have two plates. One is 12 mm and one is 14 mm. So we have studied that whenever we are designing something, whether it is size of weld or stress calculation, strength calculation, we will take the thickness of the thinner plate. So what is given as thickness of thinner plate is 12 mm, right? Next is for the purpose of stress calculation, our maximum throat thickness is given by 5 by 8 of thickness of our plate. So 5 by 8 of 12, if we calculated how much it is coming, 7.5 centimeter mm. So our answer will be D, 7.5 mm, right? Yeah. This is our next question. In case of slot welding, width of the slot should not be less than 2T or 25 mm, 2T or 25 mm, 3T or 25 mm, or 3T or 25 mm. Sorry, whichever is great, whichever is smaller. 3T or 25 mm, whichever is greater. 3T or 25 mm, whichever is smaller. What do you think will be the correct answer? C, okay. So it is given in IS 816. What is given as the width or diameter should not be less than 3 times thickness, 3 times thickness or 25 mm, whichever is greater. So your answer is correct. Answer is C, 3T or 25 mm, whichever is greater. So this is our next question. A joint is subjected to factor shear force of 250 kilonewton. This is our FPO, sorry, Q, shear force. Assuming single V groove weld joint, find the effective length of the weld if the thickness of thinner plate is 12 mm. Assume FV 410 grade and that the welds are shop welding. For shop weld, gamma is given by anyone? Okay, let us see the solution then. Firstly, we have a single V groove weld. So effective throat thickness, we are for the stress calculation, throat thickness is given by 5 by 8 of thickness of plate. Thickness of plate is 12 mm. Again, our T will be 7.5 mm. So this is our throat thickness T is given by 7.5 mm. Second thing is we will calculate effective length of weld. So how we are calculating effective length of weld? This is the formula. So you remember VDW formula we are seeing LW into FY into TE divided by under root 3 gamma MW. So V is already given to us. Shear force is already given to us 250 kilonewton. From there we will calculate the effective length of weld. Right? So in this case, what is given? Shop welding. Shop welding gamma is 1.25. V is given by 250 kilonewton, converting into Newton. Fy is given by for Fy is 250 for welding. We are taking 250 and Te we just calculated 7.5. So our effective length of weld will be, that is what is asked. How much it is coming? 288.67. So the answer will be between 285 and 290. Right?
Ma'am,
And
a small thing.
hmm,
Here, when we're calculating the design strength, we are considered a FY value, like yield strength.
I don't understand what.
I mean, here we are while calculating effective length of the weld,
Hmm.
we used FY value, like yield strength.
Huh. FI is
I mean,
250.
so here this is governing the strength of the lap. I mean, the
Joint
weld, right?
weld. Huh.
Yes. I mean, for the previous question, when we were saying that which governs the uh, strength of the by it is yield or fracture, then they should be considered, right? The yield strength is considered for the shear and the
Yeah, that was the answer, right? We are saying in that question also that yield strength is
mm, mm.
yield for axial loading as well as for shear loading.
Okay, sorry, I got a little confused. I thought fracture for both the things. Okay, right.
We are considering yield only.
Mhm.
Next question. Design strength of fillet weld done at its side for plate made of Fe 410 grade of steel is 125.2, 137.4, 146.7, 157.8. So I'll give you the formula. So this is our formula. In case of what is it? Shop at side, what is our gamma MW? Okay. So site welding gamma MW is 1.5. Somebody was asking something. So in this case, gamma MW is given by 1.5. Then Fu is given by 410 megapascal. It is already given in question. It is made by 410 grade of steel. And then last is nothing else, no? So we can calculate the design strength. It is given by Fu upon under root 3 gamma MW. Which is given by answer is 157.8. Okay. To the next question one. A twisting moment of magnitude. So this is our moment value, 12 kilonewton meter, is applied to a bolt group. If radial distance of the bolt B from the CG of points, CG of the bolt group is given by 130 mm. So this is a radial distance R value. And the summation of square of radial distance of each bolt is 87600 mm square. This is our sigma R square. Sigma R square is given by 87600. Calculate the force in the bolt B due to the twisting moment only. So we have to calculate F2 only. We have seen two type of forces, so we have to calculate F2. You can take 2 minutes and see if you can calculate it. So these are the given values, M, R and sigma R square. So M is P into E. So this was a very simple solution. F2 is given by moment into R divided by sigma R square. So PE is given by 12 kilonewton meter. We can calculate it 12 into 10 is plus 6 for Newton mm. And then R is given by 130 mm. Sigma R square is given by 87600. So our F2 value will be 17808 Newton. It is given in kilonewton. We'll convert it to come 17.8 kilonewton. Right? If axial stress Fa given by tensile or compressor and shear stresses Q are combined under the most unfavorable condition, the equivalent stress is given by, I think we have seen this question, this already. It's a pretty simple answer. Fa plus PQ square, right? This is a screenshot from Sir's presentation. F is given by Fa square plus 3Q square under root. Next question is, a pipe of 120 mm diameter and 8 mm thickness is connected to another pipe of 16 mm, is connected to a plate of 16 mm thickness with fillet weld done along its perimeter. Okay. So this is a pipe. It is connecting to a plate. So this pipe thickness is 8 mm and this plate thickness is 16 mm along its perimeter. Perimeter means along this circular path. The weld is subjected to combined loading and is found that the resulting shear stress of the magnitude 150 upon Te and bending stress of magnitude 500 upon Te are acting on the weld, where T is the effective throat thickness. Find the minimum size of fillet weld. So we have to calculate throat thickness and size of weld. I think I have to do it. So we'll just see quickly. So here what is given is this is our FU value 410 megapascal and it is shop welding. So shop welding gamma MW will be 1.25. Next is the normal stress due to bending. Fa is given by 500 upon Te and shear stress is given by 150 upon Te. So normally our equivalent stress due to these two combined stress is given by last question only we have seen Fa square plus 3Q square. So we will calculate our equivalent stress. So this is our equivalent stress. It is coming in terms of Te 563.47 upon Te. So other thing which was given is this should be less than equal to Fu upon, what was the formula? Fu upon under root 3 gamma mw. So Fu we have already 410, gamma mw 125. We will solve this equation and then we can get the T value. So from here we can get the T value. T value should be greater than or equal to 2.97 and our throat thickness is given by T value is given by 0.707 of size of weld. So S will be T upon 0.707. So H should be greater than 4.25. In this case, it will be 4.5, right? Okay. For safe, it is taken as 5 mm. I have to check this question. I think 4.5 can also be correct answer because RS value is coming greater than 4.25. Divided by 0.707 or 4.25. So the answer can be 4.5 as well as 5 mm. Anything else is given from where we can find the exact size of fillet weld. It is asked minimum size of fillet weld. So I think minimum we can give as 4.5 mm instead of 5 mm. Okay. Next question is, a bracket is connected to a stanchion by fillet welding done at shop to resist the eccentric loading applied in the plane of welding. If the maximum shear stress in the weld due to the movement is 110 megapascal, direct shear stress is 27.5 megapascal, and angle is theta is given by 50 degree. Find the resultant maximum load. So this is simple. We will use the last formula. Here, due to bending, it is given by 120. Due to shear, 27.5. Angle 50 degree. So the formula was QB square plus QS square plus 2 QB QS cos theta. So we have all the values QB, QS as well as theta value. So we will calculate our resultant stress and it is coming as 129.41 megapascal. So it is coming as 129.41 megapascal, which is in the range 129 to 130 megapascal. Okay. So this is the last question for today. It is given as a bracket is subjected to a factored load of 70 kilonewton. So our P value is 70 kilonewton and is connected to a tension by welding. So this is our welding provided. Find the size of weld so that the load can be carried safely. So what all other values is given by distance of CG of the welded area from BC. This is our line BC and this is our CG. And this X value, this is our X value. It is given as 29.38 and polar moment of inertia IP is given by 5.78 into 10 raised, this is 10 raised to power 6, not 106, 10 raised to power 6 T mm4. T is the throat thickness, take value of K as 0.707. K is calculated for throat thickness 0.707 of S. So for the size of weld and grade FU 410. Okay. So take 5 minutes if you can calculate it, then we will see the solution. So this is the X value which is given to us. First, we are calculating our eccentricity. This is the load P given as 70 kilonewton and eccentricity is from the CG point to the loading. So this eccentricity is given by this total 180 plus 120 minus this X value. So this E value will be 270.62. Okay. This is our E value. Second is IP value is given by in terms of T, 5.86 into 10 raised to power 6 T. Third is area of weld. So this is our weld. This area, how we can calculate? This length plus this length plus this length into throat thickness. So 2 into 120 T, this is our 120 into thickness T, 2 into 120 T plus this length 250 into throat thickness T. So it is coming as 490 into throat thickness T mm square. Okay. Next is the radial distance. This is our radial distance R value. How we are calculating this R value? This is our hypotenuse of this triangle. So this length is 120 minus x, 120 minus x square plus this length 250 by 2, 125 square. So this R value is coming as 54.39 mm. Okay. Till here everything is clear to everyone. So next thing is we are calculating the moment at this point. So moment is P into E, load into eccentricity. So it is load is 70 into this. So it is coming as 18.94 kilonewton. And what else is asked? Find the size of it so the load can be carried safely. Okay. So we will calculate two. Here we are not given that if it is by shear or direct. So we will calculate safely for the combined forces. So we are calculating both stresses, direct shear stress, which is given by load upon area. So load is given as 70 and the area we have calculated here, area of our weld, 490 into 3 T. So this is our direct shear stress. Next is shear stress due to bending. So same formula, sigma upon R is equal to M upon I. So from here, sigma value we will calculate. M we have already calculated. R we have calculated. R we have calculated here. This is our R. Then IT is already given to us, 5.78. So this is our shear stress. Okay. Third is the cos theta. So cos theta value is given by this length divided by this length. So if this is our theta angle, cos theta will be base upon hypotenuse, right? So this is R value. This is R value. So base is 120 minus 29.38, 90.62 divided by 148. So our cos theta value is 0.58. So we have all the terms. This is our PB, PS, cos theta. All terms we have, we can calculate our resultant stress as PS square plus PB square plus 2 PS PB cos theta, the under root. So our resultant stress PR is given by 600 divided by T. So this is our resultant stress. Another thing is our resultant strength of weld. From stress, we will calculate strength of weld. So strength of weld is normally given by Fu upon under root 3 gamma MW. This is our uh, is given anywhere. Okay, it's not given anywhere. So we are assuming that it is shop weld. So we are taking gamma as 1.25. So we can calculate strength of weld, one thing. Second is we will calculate the strength using the stress value. So this strength is given by stress value. Resultant stress will be our strength value 600 by T, which will equal to this strength value calculated from the FU. And when we are equating it, we can calculate our throat thickness T 3.17. So next what we have to calculate exactly, we have to calculate size of weld. So size of weld is given by throat thickness is given by 0.707 into size of into throat thickness. Sorry, I'm saying wrong. Throat thickness is given by points which is equal to 0.707 of S size of weld. So size of weld will be T upon 0.707, which is approximately equal to 4.5 mm. Okay. So answer will be B 4.5 mm. Okay. Is this design problem clear to everyone? So this was all about today's class. If you guys have any doubt, you can ask me now.
Yes, ma'am. Like, can you go to previous slide?
Sure.
Yeah, yeah, fine, ma'am. Anything is fine. Like, I just want to ask, like, see here we are having thick. I mean, thickness of weld is like constant one, considering constant one. Any question is given, like if length of from A to B, weld of thickness is different from B to C. So in that conditions, I mean, will the calculation what we are doing will be different, or just we have to consider area into the size of the
No,
thing.
it will be different on this. See, in this example also, when we are calculating area of weld, what we are doing 120 into thickness
Mm,
plus 250 into thickness plus 120 into thickness. If you can see here. First we take 120 into thickness into 2 plus
mm.
250 into thickness. So if our thickness will be different, so it will become T1 and this will become T2. So more
But
the variable, more the terms, more the things will be given to us in question itself to calculate these two thicknesses.
okay. I mean, I was more concerned regarding if, let's say, it was mentioned like AB, like line AB having throat thickness less than BC. Then R, where is the critical? situation, that R will be different, I guess, because R value is like located at point A from CG.
Hmm.
But if it was mentioned like thickness of AB weld is less, then R cannot. I mean that R cannot be the
Yeah, our
governing
CG will
factor.
be changed. Our CG point will
Okay.
be changed, no? So
Okay.
R will be
So.
calculated from that CG point.
Okay. Okay. Mhm. So in that situation, if that CG is given, so irrespective of any size of the weld, it will be like compensated kind of
Yeah.
thing. Okay. Right. Got it.
Other doubt?
Ma'am, one more, like not regarding to this one, regarding to sir's lecture. In one problem it was given, like it's a lap joint in for bolt connection, and the bolts are in position of there are 7 bolts. Bolts are in shape of hexagon with an extra bolt in middle. Okay, so there we are seeing for failure pattern, like where can the failure possible kind of failure. So they were calculating the bolt strength and tried for bolt bearing failure and shear failure. They have calculated and they considered list of the one for the criteria, and they also calculated for the failure of the plate also
Hmm.
for the governing which is governing, so that is fine. But when considering the failure of the plate, I mean there are different lines considered. For if the first line has the 2 bolts and the second plane has 3 bolts and all, so the first line is considered around having 2 bolts in it, that area is considered fine. But when coming to a second line, I mean that was
Telling
mentioned like,
it's like this way. One, two, three.
yes, yes,
Hmm. So
huh,
one plane will be this one, second plane will be
yes.
this one. Hmm.
If you take considering second plane, when we're calculating second plane, the area of the plate we are considering, and also considering the bolt value.
Yeah.
I mean because we had an what do you call it, assumption that the bolts will be
Good
having of equal distribution. Bolts will having the equal loads and all.
distribution. Hmm.
Equal distribution. So if that is the case 2 will not be considering the bolt values of first 2 bolts. I mean, if the failure occurs, then it cannot be possible like only 2 bolts are failing, right? Since since the assumption is like all the bolts will having the same kind of distribution of load, there cannot be situation where 2 bolts are failing and other were like safe.
It cannot be the case, but it will initiate from some point. So we are calculating which is that failure plane exactly, which is failing
Hmm.
first.
Okay.
We are taking like a critical condition. We are not saying that only one plane is failing. We are telling which plane is failing first.
Yes, the, we cannot decide that one. That's why we are calculating for every plane.
Hmm.
I was asking like, while we're considering, like let's say that second plane was the criteria. In that calculation, we considered bolt values. I think we should not be considering the bolt values.
Why we are considering bolt values is because our this coded provision is saying no that our strength value should be less than bolt value. Here we are telling now the resultant force uh, should be less than bolt value.
Hmm.
So that's why I think we are considering bolt value.
Then bolt value. Okay. Okay.
I have to see that question which you are talking about
Okay. Right, man. Fine.
to tell you exactly. Please see that question.
If you're having the PPTs, maybe I can direct you to that one. I think it
Yeah.
was in 1 second. I think it is in very first PPT, I guess.
Week
No,
three
sorry, man.
only.
Second. Week two, sorry, week two's PPT. I'm sorry, ma'am. Is it okay to continue, or will you be? Should we be discussing in the next lecture or something?
It's okay. I will just start from the people.
It was in the second PPT.
Where?
Uh,
This one?
After this question, I guess. Yes,
Yes.
this one, ma'am.
This one.
Yeah.
You can start.
If you go for the last, last page of this explanation.
Just a minute, let me read the
Yes.
question.
Yeah. Sure.
Out where? Last slide. You were asking.
Okay. Can you go previous to that one? Uh, Strength of joint along two.
Strength of joint along people. Okay.
See that, ma'am. We along with the plate strength, we are also considering the bolt value also.
Just give me 1 minute. I will charge my
Yeah,
laptop.
sure.
In this case, why we are taking both values? If you see this figure, our if our load is acting on, like, imagine this, sorry, this plate is going in this direction and this plate is going in this direction. Okay. So, for the first plane we are checking, if our loading is in this direction, sorry, this plate is going in this direction and the below plate is going in this direction. So for the first plane, we are considering only this load. But when it comes to the second plane, the stresses will be due to these bolts, as well as there will be some effect from these bolts also, right?
Why will they govern, ma'am? They shouldn't be governed. If those were failing, the triggering point cannot be from the considering those bolts also, because bolts will be getting equally. So we cannot say the line plane one. We can also consider plane three and plane one at a time. Then, if you're coming to the middle one.
You cannot consider, see, imagine See,
Because this is purely
mm,
symmetrical where plane 1 and plane 3 are same. So they cannot be like plane 1 is failing. I mean, when we're considering plane 2, along with plane 2, there is plane 1 was only failing because plane 3 is also like equivalently same.
yeah, but in plane 3 also we are taking bolt value, and that is because of the effect of 5 bolts behind it.
I mean,
So,
I was not able to convince like if you're going for the plane 3 or plane 2, why you're considering the bolt values of previous plane?
see,
Why they are
there is
failing?
some effect
Yes.
because of these bolts. If this plate is going in this direction, if a plate is
Hmm.
going in this direction, so these bolts are just simply, they are having their own load, right? But when we
Hmm.
are considering plane 2, there is some like these bolts are also holding on to something, right?
Yes,
For
definitely.
for these bolts, there is nothing at back. So the complete stress is in one direction. But when we come to plane 2, there is some stress, there is some like opposite stress because of these bolts also.
Okay.
Some reverse stress will be there, na?
Yeah, definitely it will be there.
It will be there, na?
But,
So that is,
but
hmm.
yes, yes, continue, please.
So because of that only we are considering the bolt value of these two bolts.
Mhm. Okay.
My opinion, that
Yeah,
will be the
maybe.
resistance value of these two bolts. And in this case, it will be the resistance value from the these 5 bolts.
So can I say that if the failure is passing through the second plane, there will be no situation. The plane 2 will be failing without failing of plane 1 bolts.
It is failing without failure of playing one bolt. Playing one side.
I mean, if the plate is failing at plane 2 section, so there cannot be any case where that case cannot be possible if without failing the bolts in plane 1 1.
No, there won't be a case. If plane 2 is failing, there is a high
Hmm.
chances plane 1 will be failing along with it.
I think we cannot say high chances. They should it should be like should be failing the for plane 1 1 or plane 3 3.
Should be.
I mean high
Uh,
chances
uh,
matlab.
yeah. Sorry. In case of plane 2, plane 1 should be failing. And in
Huh.
case of plane 3, plane 1 and plane 2 should be
Plane 2
favored. Hmm.
should be failing.
Yeah.
So is that right? So that is right you're saying.
Yeah.
Okay, okay. Like I just want to request you like maybe to go through any other examples and please confirm it in the next lecture or something, ma'am. Because I was little not able to
Okay.
convince is this possible or not.
You're
So
still not
that's why.
convinced. Okay. I will just
Yes.
look into some other example.
Yes, yes,
Yeah,
yes. I
sure.
mean, logically, maybe it was seems to be right where you're saying like irreversible kind of those definitely will have some load without definitely that will be there, but not to the breaking kind of level. I was thinking not to the
See,
maximum load.
when
That's why.
imagine these two bolts, this bolt and these bolts are there. This plate is stretching in this direction.
Yes.
So unless and until when this plane, we consider this plane, so
Hmm.
these bolts will be going in this direction. Stress will be there, but
Hmm.
these two bolts, they will be holding it back, right? They will be holding this plane back. That you can
No,
imagine,
I
right?
think those cannot be holding. Those will also be in the same direction. I mean, because those
Stress
are
will be in
holding the.
same
Uh,
direction, but some
uh,
resisting force will be there, na, because of these two bolts. Okay, let's see from plane 1 1. If
I
plane
mean, in
1 1
that way,
is there,
then
um,
mm,
in plane 1 1 is there, some when there is a stretch, these these bolts will be going in this direction. So at this point, if you see, there is no resistance. So these bolts
mm,
will fail directly.
yes,
Yes.
yes,
But when it come to plane 2 2, these
mm,
two bolts, they are providing some sort of resistance to this plane. So
okay,
uh, until and unless these are failing, there won't be a failure of 2 2. That is my opinion. Like I also have to confirm what you are trying to ask. But I feel like When plane 2 is failing, plane 1 will definitely fail.
Yes, maybe like now I was little convinced after drawing that one. Maybe yes, ma'am, I will also look into those any if
I
exam.
will also see if I get some more example on this thing.
Hmm. And also, sorry, ma'am, to
It's okay,
extending
it's
this
okay.
much time. Also, today's question where I was confused, where which were the governing for either yield or fracture strength.
It is
So,
actually given in slides also, like for
I
both
mean,
yield
is
will
that
be.
for only for butt weld or any weld?
It is only for butt weld, I think.
Huh, it is only for butt
For
weld.
butt weld,
Even I was
only for butt weld.
fine, ma'am. It is fine. We can continue in the next class or something. It is easy.
Case of butt weld only, it is there.
In case of butt weld only, right, dimension to butt. Okay. Why it is different, ma'am? Why butt weld is governed by yield, where other welds are governed by ultimate?
Welds are in case of fillet
Maybe
weld,
I was thinking where butt weld is like complete disconnect between one. So first plate one and plate two.
because
So
both are in
even
same plane. Maybe that's why.
plane, yes. There is no chance of like elongation. There's some elongation started. That is considered as failure. I was thinking.
Yeah, I think that can be the reason because there is no overlapping. It's just
Huh.
edge to edge is joint. So
Join.
when it is failing, it is fully going. It's not some stress is not there to hold it back. Maybe
Oh,
that's the
okay.
case.
Mhm. Yes, ma'am. Right. Yeah, thank you for your time, ma'am.
Close the class.
Sorry, ma'am.
Can I close the class?
Yes, definitely,
Oh,
definitely. Thank you.
thank you.